For centuries, humanity has looked up at the stars and wondered, what's out there? Are we alone? And could we ever travel beyond our home planet? Today, we're closer than ever to answering those questions. From colonizing Mars to dreaming of interstellar voyages, the future of space travel is becoming a reality. But how will we get there? And what challenges must we overcome? Let's dive into the exciting possibilities of space travel and explore where humanity could go next. Mars has long been our next big target in space exploration. Why Mars? Because it's the most Earth-like planet in our solar system. It has seasons, polar ice caps, and even evidence of ancient rivers and lakes. Scientists believe that studying Mars could teach us more about the origins of life and how to survive on other planets. The journey to Mars isn't easy. The distance between Earth and Mars is around 225 million kilometers, 140 million miles on average. A trip to Mars would take about 6 to 9 months each way, depending on the positions of the planets. NASA, SpaceX, and other organizations are working on spacecraft capable of making this journey. SpaceX's Starship is designed to carry both cargo and passengers, making it a key contender for future Mars missions. But once we get there, how do we survive? The Martian environment is harsh. Temperatures can drop to -80 degrees Fahrenheit, -60 degrees Celsius. There's very little oxygen, and its surface is bombarded by radiation. Future Martian colonies would require self-sustaining habitats with life support systems, greenhouses for food, and technologies to extract water and oxygen from the planet's resources. Before we colonize Mars, the Moon could be our testing ground. NASA's Artemis program aims to return humans to the Moon by 2025, with plans to establish a permanent base by the 2030s. Why the Moon? First, it's much closer, only about 384,000 kilometers away. This makes it easier and safer to test new technologies and train astronauts for longer missions. A moon base could also serve as a refueling station for missions to Mars and beyond. Scientists are exploring the use of lunar resources, like ice at the moon's poles, to create water, oxygen, and even rocket fuel. Building infrastructure on the moon will prepare us for the challenges of living on other worlds. While the Moon and Mars are within our grasp, interstellar travel is the ultimate frontier. The idea of journeying to distant stars has captured the human imagination for centuries. From science fiction to scientific inquiry, the dream of exploring other star systems is one of humanity's greatest ambitions. The nearest star to us, Proxima Centauri, is part of the Alpha Centauri system and lies about 4.24 light-years away. In cosmic terms, this is just next door. But for us, it's an almost unimaginable distance. Current spacecraft, like the Voyager probes, travel at speeds of about 17 kilometers per second, which is fast by Earth standards, but incredibly slow on an interstellar scale. At that speed, it would take 73,000 years to reach Proxima Centauri. So, how do we overcome these colossal distances? Scientists are exploring several revolutionary ideas. The first is nuclear fusion. The process that powers the sun could revolutionize space travel. A fusion rocket would generate immense energy by fusing atomic nuclei, allowing a spacecraft to reach speeds much greater than any chemical rocket. Fusion propulsion could shorten the journey to Proxima Centauri from tens of thousands of years to just a few hundred. However, developing a stable and efficient fusion system remains a significant engineering challenge. Despite this, organizations like NASA and private companies are actively researching fusion propulsion as a stepping stone to the stars. Light sails, also known as solar sails, use light to propel spacecraft. These sails are made of ultra-thin, reflective materials that capture momentum from photons, particles of light. A groundbreaking initiative called Breakthrough Starshot aims to send tiny light sail probes to the Alpha Centauri system. These probes would be propelled by powerful Earth-based lasers, reaching speeds of up to 20% the speed of light. At this velocity, the probes could reach Proxima Centauri in about 20 years. While this technology is still in its infancy, it represents one of the most promising paths to interstellar exploration. Another is antimatter propulsion. Antimatter, often considered the most energetic fuel imaginable, could revolutionize space travel. When matter and antimatter collide, they release vast amounts of energy, far exceeding that of chemical or nuclear reactions. A spacecraft powered by antimatter could theoretically reach near light speeds. However, producing and storing antimatter in sufficient quantities is an enormous scientific challenge. Current antimatter production is incredibly expensive and inefficient, but advancements in this field could one day make it a viable option. Warp drives is also a concept straight out of science fiction, involve bending or warping space-time to allow a spacecraft to move faster than light without breaking the laws of physics. The most famous theoretical model is the Alcubierre drive, which proposes compressing space in front of a spacecraft and expanding it behind, effectively creating a bubble of space-time. While space travel is exciting, it comes with significant challenges. For example, beyond Earth's protective magnetic field, astronauts are exposed to high levels of cosmic radiation, which can damage cells and increase cancer risk. Developing radiation shields is a top priority. Another is microgravity. Long periods in zero gravity weaken bones and muscles. Scientists are studying ways to simulate gravity in space, such as spinning spacecraft to create artificial gravity. Another challenge is space debris. Earth's orbit is cluttered with old satellites and debris, posing a risk to spacecraft. Future missions must address this growing issue to ensure safe travel. The future of space travel is closer than you think. In the next few decades, we could see humans living and working on the Moon, thriving colonies on Mars, and perhaps the first steps toward interstellar exploration. These advancements will not only push the boundaries of science, but also inspire a new generation of explorers. Space travel isn't just about leaving Earth. It's about understanding our place in the universe and ensuring the survival of humanity.